All right, let me pick up where I left off in the last video. So I was talking about deciding that I was going to raise these to the power first. So again, a power to a power, I multiply the exponents. So when I take negative 2/5 times 5, I get negative 2. Down here, I have the base of 3. When I take negative 1/5 times 5, I get negative 1. Now that I see that I have negative exponents, I need to flip them. Again, I could have done that first. So I'm going to get 3 to the first in the top. In the denominator, I'm going to get 2 squared. So all I'm doing is taking care of those negative exponents. And then 2 squared is 4. So I get 3/4. So you do need to make sure on the test that you're showing me the work of how you're getting these answers. Don't just write down the answer 3/4, but show me the steps of what you're doing. And again, there are many different ways to do that, or many different what you could do first. I could have taken care of the negatives first. Okay, now let's jump to the next set. This one says write in simplest form. A lot of these are going to have radicals now. So we're going to deal with radicals. So in the first one, I have to take the 4th root of 27 times the 4th root of 3. So I would probably just multiply those first and then worry about simplifying. 27 times 3 is 81. Now the 4th root of 81, 81 is a perfect fourth. 3 times 3 times 3 times 3 gives me 81. So the 4th root of 81 is the number 3. 8, we talked about sometimes it's easier to simplify before you do things, and so I can't really simplify the cubed root of 250, or don't want to, and I can't simplify the cubed root of 2, and I don't want to worry about rationalizing the denominator yet. What I do see is since they're both under the cubed root, I can do my division first. So 250 divided by 2 is 125. So now I know that 125 again is a perfect cube. The cubed root of 125 is 5. So again, there are many different ways you could do this. You could have tried to simplify the cubed root of 250. You could have tried to rationalize the denominator. All of those would be longer, but should eventually get you to 5. But if you see that you can simplify those first, make sure you do that. All right, number 9. 9 is looking to see, do you know what the cubed root of 27 is? Cubed root of 27 is 3. And then the cubed root of y to the 9th. Remember, to be a perfect cube, when you're starting to look at exponents, this number has to be a multiple of 3. It has to be divisible by 3, and it is. Y to the 9th, if I'm going to take the cubed root of it, remember it's like taking y to the 9/3 power if I put it back into exponential. That comes out nicely. 9 divided by 3 is 3. So the cubed root of y to the 9th is y to the 3rd, 9 divided by 3. So that's a perfect cube. Didn't have to do anything else with that. All right, the next set of problems is making sure that you know about like terms. So this is 7 times the 5th root of 12 minus 1/5 root of 12. So if they're the same terms, and they are, this is exactly the same as this, all I need to do is take 7 of those minus 1 of those. I have 6 of those terms. And that's it. Now when you get to number 11, they're not like terms. I have a cubed root of 5 and a cubed root of 40. So that's where we're going to use our simplifying techniques, and we're going to say, all right, I have this 3 out here. I need to break up cubed root of 40 into a perfect cube. Remember, cube roots, 2 to the 3rd power is 8. 3 to the 3rd is 27. Now right away I see that 8 is a factor of 40. So I'm going to break this up into the cubed root of 8 and the cubed root of 5. Okay, that's still the cubed root of 40, but the reason I picked this one is I know 8 is in my list of perfect cubes. So I have the cubed root of 5 plus I have 3 times the cubed root of 8 is 2. So 3 times 2 is 6 times the cubed root of 5. So I took 3 times 2 because that's simplified to 2. So now I have 1 of those terms plus 6 of those same terms. So when I put them together, I have 7 of those terms. So there are times you may have to simplify it so that they are like terms and you can add them together. All right, 12 shows you that even if it's in exponential form, they can be like terms. As long as these are the same, if I have 4 of those terms plus 8 of those terms, how many do I have? I have 12 of those terms. And there's my answer. Okay? All right. Let's see what else we have. Number 13, 14, and actually 15 and 16 deal with rationalizing denominators. So when I look at this, I can't simplify 3 divided by 4, because that's what you should look for first. So once I realize I can't simplify that, I have to think of what can I multiply this by, because I have the 5th root of 4 in the denominator that is not a perfect 5th. So I have to multiply by something so that I get perfect 5th. So we need to think of perfect 5ths. So if I think of 5ths, use your calculator. Figure out what is 2 to the 5th power. So 2 to the 5th power, let's see, 2 to the 4th is 16, so 2 to the 5th is 32. But you can use your calculator for that. So then you ask yourself, can I multiply 4 by something to get to 32? Sure, I can multiply by 8. If that didn't work, then try 3 to the 5th power and figure out, is there something I can multiply 4 by to get to 3 to the 5th? So keep working with your 5ths until you find something that works. So I know I can multiply by the 5th root of 8. Again, why did I pick that? Because in the denominator, I'm going to get the 5th root of 32, and that's in my perfect 5ths list. So I multiply straight across the 5th root of 24 over the 5th root of 32. And we said the 5th root of 32 is 2. 2 to the 5th power gives me 32. So the 5th root of 32 is 2. And I probably should make this look more like a root instead of a... So make sure when you do your root that I can tell that it is a root and not a coefficient. So the 5th root of 24 all over 2. All right. Same thing with 14. I can't simplify this, but what I can do is try to think of a perfect cube. So now cubes, 2 to the 3rd is 8, 3 to the 3rd is 27, 4 to the 3rd is 64, 5 to the 3rd is 125. So I'm looking at this list thinking, what number can I multiply 5 by to get to one of these numbers? And I see 125 is going to work. I have to multiply by cubed root of 25. So that when I take 5 times 25, that's going to give me 125. That is a perfect cube. So in the numerator, I'm going to get 7 cubed root of 4 times 25 is 100 over, in the denominator I get the cubed root of 125, and I'll just write that as 5. So you're really thinking of these lists. If it's a cubed root, think of the cubes. You're thinking of what number can I multiply 5 by to get to one of these numbers, and once I get here, I knew I could multiply by 25. Okay, when you get to 15 and 16, those are looking at rationalizing the denominator with conjugates, because I have a 6 minus the square root of 2. So then I need to multiply by the conjugate, which is the same two numbers, but the different sign. So if there's a minus sign here, I change that to a plus. Everything else stays the same. So remember, we have to FOIL things out though. So in the numerators, 3 times 6, 18, 3 times radical 2. I just have to leave it as 3 radical 2. In the denominator, 6 times 6, 6 times square root of 2, and 6 times negative square root of 2, because they're conjugates, will always drop out. So you can write them down if you want to, but you don't have to. The inner and outer product will always cancel out. But I do have to multiply the last terms. Negative square root of 2 times positive square root of 2 is a negative square root of 4. So you do have to multiply the first terms together and the last terms, because the inner and outer product will cancel out. And so in the numerator, I have 18 plus 3 square root 2. In the denominator, 36 minus 2. Remember, this is a 2. 36 minus 2 is 34. All right, same with 16. We're going to rationalize the denominator by multiplying by the conjugate. 1 minus the square root of 7. So when I do that, this one's a little bit different because in the numerator I have a square root. But I'm still going to distribute. I'm going to get the square root of 7 times 1, square root of 7, minus the square root of 7 times the square root of 7 is the square root of 49. So I get the square root of 7 and the square root of 49. Notice these are both under square roots, that's why I get the square root of 49. With this one, I just take 1 times the square root of 7. All right, in the denominator, we have to FOIL. 1 times 1, inner and outer product will always cancel out, and then I have to take positive 7 times a negative square root of 7. Again, that's a negative and square root of 49. Now, these do not cancel because there's 2 terms up here and 2 down here. So all I can do is simplify the square roots. Square root of 7 minus 7, and 1 minus 7, I guess I could do that here. So if I take 1 minus 7, because again that simplifies to 7, I get negative 6. And that's my